All right. Thank you, everyone, for attending Thomas's Scientific's first cannabis webinar. Today we have Nathalie from Restek, who will be presenting the sample workflow of cannabinoid analysis.
Thank you, Kaylee. Hello, everyone. Thank you so much for joining us in today's webinar. So I'm going to be talking about how to approach potency testing method development. And yeah, I hope this presentation is useful to everyone. So first of all, the cannabis legalization landscape has been changing quite a lot over the last years. And this map has been like very dynamic over the last couple of years. And it is very important to make sure that we have reliable methods capable of complying with the requested compliance values. So today I'm going to be talking a lot about different sample preparation approaches suitable for different samples. So first of all, it is important to mention some aspects about potency testing. And the first one is, what is potency testing? So potency refers to the quantitative analysis of the cannabinoids content in cannabis plant material, in hemp, as well as in their derived products. So accurate analysis requires of reliable analytical workflows for different types of samples. And typically, cannabinoids are tested using HPLC coupled to UV, as this approach provides reliable and robust data while keeping the costs affordable and low. And there are other instrumental platforms that are used also for cannabinoids testing, and those include LCMS, LCMS-MS, which is of course the most selective one, however, it's also expensive. And there are some other approaches involving GC coupled to FID and mass spectrometry. However, when using GC, we cannot analyze all forms of cannabinoids. So there is a broad range of cannabis products that have been introduced into the cannabis market over the last years. Those products include different edibles, as well as lotions and products like for personal care, beverages, and of course we have concentrates and flour or plant material. So finding the appropriate sample preparation method for each of the matrices we have to analyze is very critical. So the first question is how to prepare your sample. Well, it depends on the sample you are trying to analyze. So in the case of flour or plant material, the most common approach involves solvent extraction. So in this case, for example, we weighed 0.5 grams of pulverized flour in a centrifuge tube, and an extraction was conducted using 80-20 methanol water. And after vortexing and sonicating 3 times, the sample was centrifuged, and then the supernatant was diluted 20-fold, vortex, and then filter using Thomson vials. So these vials are very useful as they allow easy filtration of your samples to avoid introducing particulate matter into your instrumental system. So here we have a chromatogram corresponding to a CBG hemp flower. And this chromatogram was obtained using our Raptor arc-18 column of 150 by 4.6 millimeters. And the flow rate used was 1.5 milliliters per minute. Now, using HPLC-UV is a very reliable approach, but it is important to have appropriate LC gradient conditions to be able to resolve multiple cannabinoids. So the method we developed allows for the separation of 21 different cannabinoids under isocratic conditions. And we even included other most introduced or new cannabinoids that have been recently tested, such as CBDP and THCP. And here we have the chromatographic conditions. So I just want to bring your attention that the column used was 150 by 4.6. We injected 5 microliters of sample, and the flow rate was 1.5 milliliters per minute. Then, with the purpose of saving some solvents, because running the system at 1.5 milliliters per minute can mean that you are using lots of solvents. So this method was developed. So here we have a column of 2.1 millimeters ID, and the injection volume was just 2 microliters, and the flow rate used was 0.4 milliliters per minute. Under these conditions, it was possible to separate the same 21 cannabinoids under 10 minutes of runtime. And then we also developed a method for high throughput analysis using HPLC-UV. So in this case, a column packed with 1.8 micrometer particles was employed. The column dimensions are 150 by 3 millimeters ID. We injected 1 microliter, and the flow used was 1 milliliter per minute. So under these conditions, we were able to resolve all the 21 cannabinoids in less than 5 minutes runtime, which is pretty good. So in addition of having a robust LC method, it is important to have reliable standards. So at Restek, we have a number of individual cannabinoid standards at 1000 ppm concentration. And we also have different mixes, which are very convenient for reliable and fast analysis. So those mixes include this one that contains 3 components, 3 main cannabinoids, CBD, CBN, and THC. And then we recently launched the Neutrons 9 mix that contains 9 different cannabinoids at 1000 micrograms per milliliter. And last week we launched this product that is called Acid 7 that contains 7 major cannabinoids that are acids, and their concentration is also 1000 micrograms per mil. So you can easily pair the Acid 7 mix with the Neutrons 9 for more comprehensive analysis. And why is that is so important or convenient to use high concentration cannabinoid mixes? The first thing is that they help us reduce time, expense, and error related to in-house preparation of standards. And they maximize the flexibility in the preparation of calibration curves, so we can have more cannabinoids in the same calibration solutions. It facilitates sample spiking when developing potency methods. That is very helpful. So having mentioned this, I want to move now to cannabinoids, cannabis concentrates, which are also a very common matrix. So cannabis concentrates can be very sticky and kind of hydrophobic. So for their analysis, we use 0.5 grams of sample, and we use isopropyl alcohol for solubilizing the sample. So after vortexing and sonicating for 15 minutes, We aliquoted 0.5 milliliters in a 4 ml vial. We diluted that 8-fold with water ACN. And after vortexing, we aliquoted 100 microliters and diluted 10-fold once again. So here we see a representative chromatogram for a CBD isolate, and the LC conditions used were the same ones previously described for flower. Now, we have been recently hearing a lot about isomers when talking about THC, and there are lots of different isomers that have been recently reported. And the main difference in between these four compounds is the position of the double bond. So we have here delta 9 THC, delta 8 THC, exo THC, and delta 10. And due to the different number of inquiries we have got about isomers, my colleague was able to develop a method that allows separation among these four different isomers. So for this purpose, she used a Raptor fluorophenyl column, and she was able to resolve the four isomers in less than 4 minutes using the conditions shown in the slide. So if you want more information, you can visit our blog here in the link below. Then we also know that cannabis edibles are a very popular type of product, and there is a broad variety of them. So we have worked with different edibles trying to find the best conditions for cannabinoids testing. So in this workflow, we were working with chocolate, and the first intent of this workflow was to analyze pesticides, but after trying it, we were able to confirm that this sample preparation method also works for cannabinoids testing. So it involves weighing 0.5 grams of sample in a 4 milliliter vial. Then we homogenize this with 0.5 milliliters of isopropyl alcohol. So as we can see here, the sample is completely solubilized. This was dark chocolate. And after vortexing for 30 seconds, we added 2.5 milliliters of acetonitrile acidified with 1% acetic acid. We vortex and centrifuge, and then here we are able to see that there are like two layers. We have a supernatant, and the chocolate solids went to the bottom of the vial. So we took an aliquot and we mixed it with 75-25 ACN water, and we centrifuge. So this step was really important because that helped us precipitate fats that were solubilized in the supernatant and allowed us to get a much more clear extract. So here we have a chromatogram obtained after spiking chocolate with cannabinoids at a concentration of 0.2 milligrams per gram. And these are the 6 cannabinoids that are listed in California regulations. And then we verified that our workflow was being effective because, as you can notice, we only use 3 milliliters of solvent. So we compared the results that were obtained using 3, 6, and 12 milliliters of solvent, different proportion, the same proportion of isopropyl alcohol ACN, just different volumes. And as we can see here, the concentration estimated using CBD infused chocolate was equivalent, and the difference was very close in all the cases, meaning that yes, that we can perform satisfactory analysis of these cannabinoids using only 3 milliliters of solvent. Then after verifying that our method was working, we spiked samples at 3 different concentration levels, 0.2, 0.5, and 1 milligram per gram. And here we can see the results for the different levels and the coefficient of the determination. If you are interested in reading more about this work, there is a peer-reviewed paper that was published in Journal of Separation Science, so you are welcome to visit. This open access. Now, gummies are a completely different matrix. They are dealing with gummies is something much more different than dealing with chocolate. So gummies, first of all, are water soluble. And when you try to pulverize gummies with dry ice or liquid nitrogen, yeah, you can get a nice powder, but when it reaches room temperature, it becomes very sticky and difficult to work with. So based on that, we decided to just chop gummies using scissors. And for this workflow, we weighed 1 gram of sample in a 50 milliliter tube. Then we added water and we solubilized the matrix by vortexing, using a shaker in the lab. That can take between 1 to 3 hours, depending on the shaker that you have available. Then we added 5 milliliters of acidified acetonitrile. And after vortexing, we used our Ketcher salts. In this case, we use the ones corresponding to the European method. And then we vortex and centrifuge to get the different layers. And then we took 100 microliters of the supernatant and we mixed it with 900 microliters of 75-25 ACN water. And here we have the results for 6 different cannabinoids spiked in gummies. As you can see, the accuracy values were within the expected range. The error was less than 7% in all the cases. And the results were pretty good at the 2 different concentration levels tested. I forgot to mention that if you are interested in getting more details about this method, you can visit our website. Then we also have beverages, and beverages are sort of water-soluble matrix. So we know that to be able to solubilize cannabinoids in a beverage, it is typical to have emulsions. So analysis of cannabinoids in these samples requires that we break up those emulsions. And in this workflow, it was possible to perform successful analysis of cannabinoids by first sonicating the carbonated beverages and then taking a 10 milliliter aliquot, mixing it with ACN, and again using Ketchers, using the same salts that I use, that I previously mentioned we use for gummies. And then after vortexing and centrifuging, we were able to measure cannabinoids in an aliquot of this supernatant. And here we have some results that correspond to different types of CBD-infused beverages, including sparkling water, drink powder, and different other beverages. So in the table, we can see the CBD milligrams label claim per container, the experimentally determined milligram CBD, and the difference in between the concentration determined experimentally versus the one claimed on the label. So we can see that in many cases, the differences are pretty low, and in some cases, the differences are high. And this not necessarily means that the method doesn't work, is that sometimes the product itself is not stable enough and the cannabinoids can stick onto the walls of the container. So my colleague was able to verify the proficiency of our method by getting a matrix proficiency test. So this test contained 5 cannabinoids at unknown concentrations, and she determined the concentration with our method and submitted the results to the supplier, and then she was able to verify that the method properly works. So this is a very reliable method. And finally, I would like to talk a bit about analysis of lotions and balms, since these are also very common matrices and very tricky ones. So in this particular workflow, we wanted to develop a method that was sort of universal or that could work with the different lotions and balms that are kind of available in the market. So the method was developed by using 0.5 grams of sample and spreading that evenly on a centrifuge tube. Then a mix of methanol MTBE was added. And then after vortexing for 90 seconds and shaking this mix for about 5 minutes, the sample was centrifuged and 50 microliters of supernatant were transferred into a vial and evaporated. And then the sample was reconstituted with 2575 water ACN. Then 300 microliters of this extract were transferred to a Thomson vial. And here we can see a chromatogram representative of a CBD cream. And this method was successfully tested in different lotions, creams, and balms. So here we see that 9 different products were evaluated. The same as in the beverage case, a comparison between the experimental and the CBD label value was performed. And as we can see here, results in terms of precision were really good. And here we have the difference in between experimental and the CBD content specified in the label, on the label of the different products. So in all the cases, most of the cases, the results were like in agreement. There was this particular product that showed about 20% difference. And then in order to verify that the method was working, a comparison between samples spiked prior to sample prep and extracts spiked after sample prep was conducted. And here we can see results in terms of recoveries, which were all pretty good, demonstrating that we were not really losing cannabinoids over the sample preparation method. So finally, I would like to mention some of the conclusions. And the first one is that your sample prep should be tailored depending on the matrix you are dealing with. So if your sample is hydrophobic or if it's a plant material, you can try solvent extraction, or you can also try catchers in cases where the sample is water soluble. It is important to save instrument time and to ensure best data quality always. And the method that must be that is ideal for your lab maybe is not the ideal method for another lab. So you gotta pick a method that fits your lab needs, and that can depend. So reducing solvent waste, either on your LC method or on your sample prep, is always a good idea and feasible option. So you can like try that. And sample preparation is really essential for complex samples, and it's very important to keep your instrument up and running to ensure sample reproducibility and to ensure maximum column lifetime. And here we have a list of different products that can be helpful for your sample preparation method development. So we have standards, different salts, tubes, vials, and you can always reach out if you have any questions. We will be happy to help you find the right products for your sample needs. And here we have some additional resources. If you are interested in getting to know more about cannabis testing, you can visit our website. We have lots of different articles and blogs related to cannabis testing, as well as different videos that can be helpful in method development. And with that, I would like to thank my colleague, Jamie York, who is also an application scientist in my group, to my manager, Justin Steimling, and thank you all for your attention. And if you have any questions, I'll be happy to answer. Thanks.
Thank you so much, Natalie.
Thank you.
All right. Ross, do you want to queue up your slides and we'll move into the next portion of our presentation with Ross Hansen from Axcend HPLC. They have a portable HPLC system that is really unique in its flexibility for the cannabis market. And Ross, you are muted, so unmute and then you can go ahead and start.
I knew I was going to do that. Hi, everybody, and thanks, Kaylee. My name is Ross Hansen. I'm the Vice President of Sales at Axcend. We do some things that are different than what you've seen before in the HPLC market space, and so we'll talk a little bit about that over the next 20 or 30 minutes. While we will focus primarily on the cannabis and hemp markets, you'll see that we talk about a few other market spaces as well that I think will be of interest to some of our listeners. If you have any questions or after the webinar, you feel free to email me at ross.hansen@axcendcorp.com. Or if you're really dying to talk to me, call 941-356-3722. You're always free, by the way, to contact your Thomas scientific reps who have full access to everything at Axcend. They're one of our best distributors. So as we move on,
Hey, Ross, I think you're muted again.
how that happened. Okay, so an introduction to Axcend. We were founded in 2016 by Milton Lee, a professor at Brigham Young University. If you've never heard of him, the magazine Analytical Scientist named Milton, I think it's the 7th year in a row, as one of the 100 most influential analytical scientists in the world. Milton has invented everything from miniature mass spectrometers to supercritical fluid instruments to our latest introduction, which is a portable HPLC. And yes, I meant that, a portable HPLC, an instrument that literally you can pick up with one hand and walk around with. And I'll tell you all about that in a few minutes. We've won some awards and some grants that I think you would want to know demonstrate our expertise in the field. I won't read them to you. You can read them for yourself, but I think you can see that we've been chosen by a variety of people as worthy of notice and of worthy of funding. So I think it's important to know that it's not just what I'm telling you, but a lot of people have looked at our company and said, yeah, that's something we need to look at. Why? Because what we've come out with is a binary gradient pumping system with high pressure mixing at 10,000 psi, which is a very high pressure for capillary flows. You'll notice that our flow rates are very low. Natalie, our previous speaker, mentioned that one of the most important things we can do as we do these analyses is save solvents and save the creation of waste. And as you'll see in a few minutes, one of the things that we can do that nobody else can do is run all week on a little vial of solvent. It's hard to believe, but I'll show you how in a minute. It's so portable, you can see that one of our scientists is walking around outside. He is running the instrument And I would add that he's running it on a battery from his cell phone. You can actually run our instrument from an app on your cell phone. That means you can review data, reanalyze, integrate whatever you need to do anywhere, anytime, easily. What's so important? What's so exciting about our LC? Well, let's talk about savings and how much it costs to run a traditional HPLC for you per year. Now, you might look at these numbers and go, well, you say that acetonitrile is $153 a liter, but we don't pay that much. It doesn't matter how much you pay for acetonitrile. What matters is the ratio. Whatever you pay, you're going to cut it in half or better, and then you're going to cut it again. For every dollar you spend buying HPLC solvent, you typically spend $1 disposing of solvent. We can cut that from, in this model, $32,000 per year to $250 per year. I would also note that they use, to run a normal LC, much as Natalie just described, a regular 4.6 millimeter column, you're going to use something like 92 liters of solvent, of acetonitrile a year, and generate about 184 liters of waste per year. We're actually going to generate something like a liter over that entire time. So your savings are going to be tremendous. Now, one of the questions you're going to ask yourself, and I know I would ask myself, I used to work in a lab. I was a forensic chemist in a crime lab in New York. One of the things I wanted to know when somebody wanted to sell me something new is, does it work? It's great that you've got this, Ross, but does it really work? Well, how good is it? Let me assure you that if you're a chromatographer, you look at this chromatogram and you think to yourself, boy, that's a great capillary GC run of a bunch of polyaromatic hydrocarbons. But the cool thing about this is it ain't GC. It's HPLC. You are not getting peaks like that from a 4.6 millimeter column, or frankly, even a 3 millimeter or a 1 millimeter column. Our column diameter is 0.15 to 0.3 millimeters, which gives us less band broadening, less expansion to the walls of the column. We get sharper peaks, more peaks, higher peaks. So not only can you get more peak capacity, but you can also get better signal to noise, more sensitivity. So if you want to look at the trace components of the cannabinoids that are inside inside hemp or cannabis, we can see it better, we can see it more clearly than any other HPLC in the market. And I'll show you some examples of that. We offer a variety of data systems. Everybody has a data system they love. Well, we picked 3 to standardize on. One is our own software, which is included with the instrument for screening, and it's very simple and intuitive. We have taught total non-scientists, for example, U.S. Air Force personnel or sailors in the Navy or oil field workers to use Axcend Drive in a way that gets them data. But if you need more sophisticated data analysis, and most of you will, Agilent's Open Lab and ChemStation are available. Data Apex Clarity is available, and Chrome Perfect, which is a software package, is also available. So how sophisticated your software should be will only depend on how sophisticated you need it to be. You're not forced to choose the only thing we sell you. You can work with a variety of systems that you're most comfortable with and that meet your needs. Most flexible. We offer auto samplers, we offer mass spectrometry, we offer diode array detection, we offer temperature control. All of the things that you're used to seeing in a full-sized LC, you can see in our LC, with the exception that you can't pick yours up by one hand. Let me just show you some data from, these happen to be drugs that we ran. We happen to have run them on a portable HPLC-UV MS system. What you see here in the corner is a microsaic mass spectrometer. It weighs about 80 pounds. I wouldn't say that you're going to carry it around in your hands, but you can put it on a cart and take it somewhere. And for a nitrogen source, you can use a simple lecture bottle of nitrogen. It's designed for low flow, so you can take it anywhere. A grow house, a field, a sample site where you need to figure out, maybe we're blending our components right on the spot, and we want to know, did we get it right? You can take this right to the blending spot. We can also do LCUV under different conditions. This happens to be another selected ion monitoring mass spectrometry experiment. You can see that you can look at compounds in a variety of ways, UV, MS, or UV and MS. We also interface to what's known as a TSQ, which is triple quad mass spectrometer. As Natalie mentioned earlier, triple quads are the, if you will, the best in class choice for analyzing cannabinoids. They're fairly expensive, but if you need to use them, you can use them, and we got them. Let us know and we can help you out. We looked at plant materials in the field. We looked at plant materials in incoming quality control. But we also looked at, and this is where we think you're going to really see the difference with our system out of anybody else's. When you're doing initial extractions, how efficient was your extraction? Do you really want to send that extract to the lab and wait 24, 36, even 48 hours to get the answer back? Or do you want to just take a syringe, make a quick injection, and get an answer? Did I get most of what I expected out of my matrix? As Natalie mentioned earlier, again, and we depend on the Restek people for our methods. We work with them routinely. Getting the best results, you're always going to have to fool around a little bit with your extraction methods based on the matrix. Natalie did a great job of helping you to see what some of those are. What we can do is help you to optimize your extraction techniques right on the spot. And then when you're ready to send the material out, outgoing QA, QC, obviously a generation of certificates of analysis, all of that can be automated with the Axcend Focus LC. And that's really one of the things that we bring to the table is from soup to nuts. You make an injection out of the printer, comes an actual certificate of analysis that you designed, and it does it the way you want it to look. We can also do final formulation product testing and generate the same results. One of the things we did to show the usability of this was we actually went to a greenhouse, a hemp farm in Utah. Our company is headquartered in Provo, Utah, near the BYU campus. And you can see that what we did is we just did a fast cannabinoid profile. In hemp, one of the critical factors is how much THC is there, because if it's over 0.3%, if you're in the hemp business, you know you can't sell your crop, you have to destroy it. We happen to be running at a fairly low flow rate, and we used very little solvent to do this. We equilibrated for about 3 minutes and got this chromatogram, and you can see we got a great result. Everything resolved to a factor of greater than 1 or baseline resolution, and we did it in about 6 minutes. We could have gone faster. We just didn't choose to, because at some point, how fast is fast? We also ran 12 cannabinoids in under 20 minutes. We've gone as far as 21 or 24. You know, everybody has a different set of cannabinoids they want to look at. So we didn't try to do every cannabinoid and every method and every possible perturbation. You know as well as I do as scientists that you're going to do the ones that make sense to your business and your needs. So here's 12. We did them. You can see that we actually used the Restek standards, much as Natalie recommended. We're great fans of the Restek team, and we work with them closely. The hemp flower extract, and of course, what's most important of this, and know what we did. We took the LC right to the greenhouse. That's one of our scientists, Dr. Paul Peden, showing the results to somebody in there. Basically, what we did is take it, shake it, filter it, shoot it. And you can get the relative ratios pretty easily And as you can see in this case, THC never showed up. Thank you, Lord, we can sell our product. So that's a great result, and that's what we wanted to get. When should you harvest, and is it urgent that you harvest right now? Keep it under 0.3%, you have a sellable crop. The minute you go over 0.3%, you have to burn it according to the law, and nobody wants to burn their crop. We're in this business, all of us, to make money or to do science. We've got to be able to do it in a way that generates the revenue that keeps our businesses alive. How good is our system? One of the things that Natalie did so nicely, and I want to share, we shared, the R squared values. You'll notice that we're getting R squareds that are in the 3 nines to almost 4 nines. I will remind you that for R squared values, 1 is perfect. So if you're getting 3 nines anything, you're getting a heck of a chromatogram. And more importantly, you're getting something you can put with confidence on a certificate of analysis and be sure that any challenge you face, you're going to have the data to support your analysis. You'll notice that the RSDs we get, again, over here in the RSD column, these are amazing. Under 0.5%. I mean, how do you not love these? Up to 2% over here, but still great RSDs for the work that we're doing. And if you've ever worked with plant materials and natural product extracts, you know that that's hard to do. We get it because we use such good chromatographic tools, and the LC is so reproducible and so accurate. I can assure you that chromatogram I showed you for polyaromatic hydrocarbons, if you're not doing capillary, feel free to give it a try. You won't even come close. We know we can do things that no other HPLC in the market can do with normal bore HPLC columns. There's lots of other places you can use it. I won't go into them all. You can all read. But for the last slide, what I really want, or maybe it's the next to last, what I wanted to show you guys is how rugged it is. That's Sheldon Henderson, one of our scientists at the time. He's since retired, but Sheldon actually took the thing to a snowbank and started testing for pollutants in snow. What other LC can you take anywhere like that and do your testing where you need to do it? One of our taglines, bring the lab to the sample. Do your work where it makes most sense to do your work. Don't just do it where the LC is allowed to be. We think that makes so much more sense. And by the way, if you're struggling for bench space, if you're running out of bench space, wouldn't you rather have the footprint of this than a full-blown Agilent Waters Thermo anybody else LC? You can't put those where this goes. We just give you more power in a smaller space. And I won't even talk about total cost of ownership, because it amounts to, after about 3 years, the instrument was free based on the amount of solvent and waste disposal costs that you'll solve. It's a great instrument and it does great things. Thank you for listening. Again, if you have any questions, my name is Ross Hansen. You can reach me at Axcend or reach out to your local Thomas or Restek rep. They're happy to talk to you too. We're all a team and we're all happy to help you to be greener, cleaner, and frankly, more profitable. Thank you so much.
All right. Thank you so much, Ross. And thank you, Natalie, for these wonderful presentations that you did. I invite everyone to check out the Thomas Sy website. We are currently updating the cannabis portfolio and expanding and highlighting these various wonderful brands that we have. Thank you for attending, and I hope you have a great rest of your day.
Merry Christmas, everyone.
Merry Christmas. All right.